Hello. Okay, now it works. Cool. Hello, everybody. Welcome. Welcome. Uh, if I click the slides are not on the screen yet. Just so you know. Okay, cool. Welcome. So, hopefully, you're all here because you care about the world being a better place, a greener place, a more sustainable place. We have some very interesting talks today to kind of inspire you, give you some ideas, make you aware of what sustainability means and what it covers. And then later today, we're going to group you into some groups based on your shared mutual interests and what you might want to do for the hackathon. And you can share ideas, you can share sketches, you can share post-it notes, you can share Miro, you can share code. You don't have to share code. It does say code your way to a greener world, but it's not required. And then tomorrow is the actual doing day. So today is kind of the inspirational day, the motivational day to kind of get you excited and interested and thinking, that kind of stuff. So, welcome. This is run by Tecna's networks, so climate and developer network, which is not on there, but pretend there's like someone with a keyboard somewhere on there, and that's us. Tecna has many different special interest groups within Tecna, and we run events like this. We run Advent of Code, pub quiz, all these kind of different things to kind of improve the developer network inside Oslo and Norway. Yes. So if you are a Tecna member, you might see something here that interests you. If you're not a Tecna member, this might inspire you to sign up. We have people who work with space, climate, science, programming, all that stuff. And the goal is basically we are a chance for you to network with other people who have similar interests and improve yourself, improve others, improve the world, hopefully. You don't have to be a member of our network to join these events. You don't have to be a member of Tecna to join these events. But if you are a Tecna member, it's good if you do, because then we can send you emails. So sustainability, I really like this from Jurassic Park. You were so preoccupied with whether you could, you didn't stop to think whether you should. And that's specifically relevant for us in tech. Whenever there's a tech bubble, whenever people get excited about the newest technology, they go all in on trying to use it for everything possible. But once they use it for everything possible, then it's a little too late to say, oh, actually, maybe we shouldn't do that, most of the time. So this is the big fancy dinosaur. You know, there's the music when people get out of the car and they see it, and dun 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 dun, etc. All the things that can be promised by modern technology, AI tools, smartphones, out-of-season food, JavaScript on the back end. But if you only think about the nice, friendly herbivores that don't eat people too much, you also have the T-Rex. The T-Rex who wants to eat people. And that's AI, social media, inequality, oil, climate change, polarized opinions, food waste, etc. These days, we are Chris Pratt trying to train the dinosaurs, because the dinosaurs are already loose, they're already out there, but maybe we can improve the world if we can work with them in a more sustainable way. This is the program for today. It's a lot of text, but we first have a bunch of speakers, then we have QA and grouping you into teams based on your interests. And it says mingling, but it's actually more about getting to know other people on your team, sharing some ideas, sharing some inspiration, discussing the talks that have already been. And that's the plan for today. And then tomorrow, which is not mentioned in that slide, Tomorrow is the second day of the hackathon. I highly recommend you come. We're going to be here from 9-ish. No, 10-ish. 10. Okay. We're going to be here from 10-ish. And we will spend the whole day making things, sharing ideas, discussing, and with a demo at the end to see all the cool things that you came up with. Yes, okay, I'm out of slides. So the first speaker is Antoine Lacoste from Deloitte. Welcome to the stage. And clap. Clap, clap, clap.
I feel like a rock star. Hi, everyone. Welcome, and thank you for joining. So today I would like to basically continue on the line that you've started, Noah, which is about talking about technology and sustainability, but also the double impact it has and can have on sustainability. Because we often discuss how great it is that we can code our way to a greener world, that we can have technology that can help us, solar panels and what else. But I want to go a bit into also the negative aspects of it. But first, a little bit about myself. So my name is Antoine. I work in Deloitte in ESG technology. I've lived in Norway for 2 years now. I have more of a technical background, but recently I've been getting more and more interested in sustainability, and I've veered toward this area. So now I work mostly with ESG tech implementation, green IT, trying to raise awareness, educate some of our clients at Deloitte about the impact of their IT estate, and yeah, generally just trying to find good ways of using technology to solve some of our sustainability problems. So first, we're going to start with the basics. I don't know, it's going to be hard for the ones online, but for the ones in the room, could anyone tell me when the UN first coined the term sustainability? Which year? You can use the beautiful examples here to guess. 85? Close. Very close. Yes. In 1987. So it's a bit weird because it feels very recent and a bit old at the same time. But this was technology in 1987. So of course, at the time, it was extremely complicated to start guessing, oh, yeah, there's going to be a huge connection between these two, and we really need to start thinking about technology and sustainability as a unit on a lot of aspects. So technology, it's a journey, right? Your PC starts as raw material, it's then processed, transported, used, and then you have to recycle it or the end of life. There's a lot of impact across this whole journey. Today, we have decided to frame it a bit into the use area of it, because that's where we really meet across the 3 elements of sustainability. So environment, social, and governance. On the environment, there's multiple ways technology can have a bad impact. And I'm going to start with cryptocurrencies. And I know here there's a lot of people who are super good with cryptocurrency, and I've decided to make it as easy and as digestible for all of you to understand. So cryptocurrency is the money, and blockchain is the technology on which it's based. And basically, blockchain is just a way of understanding who's owning this cryptocurrency. And by doing so, we just say, you're owning, for example, a cryptocurrency because he was the previous owner and had a transaction with you. And before him, it was her, and so on and so on. And so when all of it is linked together, you have a vision of who's the real owner, and everything is saved without having a third party being able to say, you're the owner or not. So what is the problem? Well, the problem comes from how do we do these transactions and which model we decide to use. So Bitcoin, for example, uses a model called the proof of work model. So let's say a man wants to transfer a Bitcoin to a woman. He's going to initiate the transaction, and a huge amount of people in computer work actually is going to try to compete to approve that transaction. Ultimately, one of them, generally the one with the most computing power, gets to approve this transaction and register it on the blockchain. And for that, they're rewarded with a transaction fee and a sort of competition fee, if you want. And the Bitcoin is transferred. Back all of this, there's a huge amount of computing power that is necessary. And this power comes often from a part of fossil energies. So one transaction with Bitcoin has actually the impact of 402 kilograms of CO2. 402 kilograms of CO2, it's a Dutch family's energy need for 3 weeks. Quite a lot. And then you have other methods. For example, Ethereum uses the proof of stake model. And there, we initiate a transaction the same way. People with Ethereum, a certain amount of Ethereum, are allowed to validate that transaction. And random, we just decide who's going to be the person who's going to be able to validate it, and they can log it on the blockchain, and they get rewarded for it. That uses far less energy, and just a few grams, if I remember correctly. Yeah, 55 grams. That's just 15 times a credit card transaction. It's way less. It's not perfect, but it's already way less. In the world, cryptocurrencies use the same amount of energy as Argentina. Obviously, a lot of it comes from fossil fuel. It's huge. And of this, all the cryptocurrencies in the world, 66% is going to be Bitcoin because of this proof of work model. So we could say, yeah, but let's just replace all the energies. Let's use more solar power. Let's use more hydroelectric. And it's going to be better, right? Well, it comes back to what you showed us with Jurassic Park. It's not because you could that you should. There's a long way until we're all 100% renewable on energies. In the meantime, we shouldn't be using the little we have of renewable energy to operate some unsustainable transaction process on cryptocurrencies. Then another aspect I want to discuss, it's cloud and server usage. This is getting a bit more attention at the moment, but data centers and cloud today represents 3% of all CO2 emissions. And a data center, on average, can use up to 6 million liters of water, average 5 for the big ones. It is huge. And data, if you consider all the data that's been created since we started creating data on computer machines, more than 50% of the data has been created in the last 2 years. So we have a growing need from year to year. It's really going exponentially to have these data centers in place. And the problem is, well, if you want to build a data center, it's going to take a lot of space, right? So where do you want to build it? Where real estate is super cheap. And where is it cheap? In areas where it's desertic, it's hard to build a city, it's hard to have commercial buildings. So, for example, 1/3 of all data centers in the US are in Texas and California, and we've all heard recently about the real problems of droughts and water resources in these regions. Then there's the hidden cost of streaming. And this one is more, overall, it's not going to have a huge impact. You accumulate everyone using these streaming devices, streaming services, that you realize what impact it can have. So I've taken the most popular song on Spotify ever streamed, 4.5 billion times, Blinding Lights. It's the equivalent of more than 12,000 times London, New York, London with a plane. Netflix or similar streaming devices, services, if it was a car, how far would it travel? Like a car, like emitting a normal amount of CO2, how far would it travel in 1 minute? Can anyone guess? That's a lot. No, it would travel 80,000 kilometers. So it'd go around the globe twice in a minute. Now the social aspect. Now I'm going to try to introduce you to AI, and I'm going to feel like I'm not the expert here, but I'm going to try. So let's say I want to create a code, I'm going to create my little code, and the goal of this code is to identify if it's a muffin or a chihuahua. I'm going to have to train my robot to be good at this. So the robot is going to take the first picture. It's going to say, that's a chihuahua, right? No. So you basically punish your robot. You tell him, you're wrong. And we go to the next picture. And he tells you, that's a chihuahua. And you say, of course it is. And you already see this robot is super smart. And it's super useful. And basically, you're going to be training the robot to be even better than humans at one point to detect if it's a chihuahua or a muffin. You can start already doubting if it's really useful to society. But the power is there and can be used, obviously, for other applications, which we're going to discuss later. The problem is, what data do you submit to your robot? You will basically, by coding your robot, sort of transfer your own assumptions, your own bias to it. So if saying the robot is going to be perfect at doing what it does, he will, but he will perfectly execute what you've coded him to execute. The data set at the same time, you're choosing what you're submitting to your robot. You're choosing if you're going to show him only chihuahuas, or if you're showing other dogs, similar dogs, Pomeranians, for example. And that can cause some big problems. So I'm going to use a few examples of AI having probably been used badly or turned badly in the past. Who remember Ty on Twitter a few years ago? It was Microsoft's attempt at creating a sort of chatbot you could converse with, submit some tweet, and the chatbot would basically learn from its experience with the Twitter users. And obviously, 24 hours later, people had submitted so much, we'll say, hateful, racist comments that the robot became trained to think that this was perfectly normal. And so it started posting some really atrocious messages that had to be turned down. The second, and it's linked to what I discussed just before with Chihuahua and muffins, because if you take this logic and you apply it to detecting skin cancer in function of which mole you have, well, it's wonderful. We can have an even more accurate tool than we could have doctors trained for years. But what has happened when they try to put this in place is that the data set they used was mostly people with fair skin. And so when people with darker skin complexion went to get tested, the robot was actually not as efficient at all. And they actually had a lot of false positive, false negatives. So a robot which was not delivering the same quality of service to people in function of their skin color. And then we have loan discrimination. An AI system, for example, built to detect whether or not a certain client should get a credit for their apartment. Because of the way it was built, because of the bias for the people that were built, the banks, it started basically being a perfect version of their imperfections. So where a banker would have some bias towards minorities, but sometimes having him a little bit of, okay, but let's make it work. Well, the robot that was coded to apply the exact method will not have this sort of bit of humanity in him to kind of reverse that logic. And so they ended up with a robot that was even more discriminating towards these minorities. And then we have, I guess everyone here knows him. At one point, he was more Google than, I think it was Donald Trump or Lady Gaga. It was insane. Andrew Tate. And I want to use his image as a sort of example of everything that can go wrong with internet culture. So he, just quick summary for the ones who wouldn't know him. He's a sort of influencer, super masculinist, extremely misogynistic. Now he's been arrested for human trafficking as well. Like, all in all, just, I think, one of the worst person this planet has ever produced. But he's a sort of symptom of a deeper problem we have on internet. We have forums like Reddit or 4chan where there is a very, very limited amount of moderation. And you quickly get sort of harbors where people with like-minded views around racism, misogyny, can just stay together and fuel some hate, and which sometimes can turn into really disastrous events. There's quite a long list now, sadly, of school shootings, of rape, of really disastrous behaviors that were fueled by these online forums. A few statistics about incel culture. So incel culture comes from involuntary celibate. And it's basically men, mostly heterosexual, white, who blame women for all the problems and for the lack of success with them or lack of success in life and so on. And on these forums, they can group themselves. And it doesn't help if you're only around people that are suffering the same problems. You only get the freedom to discuss your problems in such a way. And it quickly turns into misogynistic comments and dangerous talks and actions. So we estimate around 100,000 people are incel today. This number is 8 times more than it was 6 years ago. And the police is now, I think, has 100,000 people throughout the world that are being monitored or considered incels on forums. There is 59% more mass murder posts on forums than there were 18 months ago. There's a rape post every 29 minutes. 89% of the people on 4chan consider that it's completely acceptable to rape a woman. It's dangerous. It's not. Obviously, it's a small fringe of the population, but we can see, and I think, unfortunately, no one has seen what one-man action can do. It can be really disastrous. Following on, governance. So there, I'm going to use an example of a man who has passed away now, not him, the next one. I'm going to use Vladimir Putin and basically the Russian government in its entirety. What they do is they utilized Prigozhin, which then became very known, but they utilized him to basically conduct the dirty work while not getting their hands dirty. And so Prigozhin built up something that was called the internet, something like that. And he basically built troll factories that were there to basically bombard Twitter with pro-Russia posts, pro-Trump posts, to basically try to influence the election. 19% of all tweets in 2020 were coming from Russian troll farms. And what it does is, this was one use case, but what it does is it basically supports the Russian government line without getting the Russian government involved in it officially. And it's a concept called plausible deniability. And then, of course, this concept can be applied also through warfare. And that's the whole concept of the Wagner Group, where it's not a Russia government military group, but it can still push forward the Russian agenda, serve its interests without getting any basically official backlash on them. Next subject, and there I'm going to put a bit of a disclaimer because I'm discussing technologies, and here it's something that was introduced in China at the start of the 2000 years. They've tried to ramp it up, and then there's been some problems with it. But it's obviously very inspired from a Black Mirror episode. It's the China's social credit score system. So again, this is what it could potentially do. It was at the start of it strongly in the idea of the Chinese government to have a sort of integrated scoring system that would group the financial data with more social data and try to pull it together to create a super score. It hasn't come to fruition. They've kind of rolled back on it. But here I just want to showcase what we can do with technology that could be disastrous as well. So the concept would be we pick up a few points where we collect data on an individual. And basically you have the traditional inputs, so income tax, payments, utility bills. Most countries in the world today are able to pull this sort of data. Then you have social inputs, so traffic rules, how you drive, have you been sued by court, and so on. And then you have the third one, which is where it would push the boundaries a bit further than what we have. That would be the online input. What are your shopping habits? How do you interact with others? Are you reliable on the info you post, or are you posting a lot of like the election of 2020 was robbed and so on? And that would give you a score. And this score would lead to benefits and disadvantages. So if I take an example, I'm a senior consultant. I have 800 as a score. And I start saying, I really like my job at Deloitte. It's wonderful. Love my life. I get points. And it continues. I have a good financial credit history. I take care of my grandparents. I do some charity work. I donate a bit of blood. I get benefits. I get easier access to cash loans. I get fast-track promotion at work, so now I'm a manager. I get priority for school and education, cheaper public transport, shorter queues in hospitals. The benefits can be whatever, right? Free gym facilities as well, not too bad in Norway. But the problem is, I guess I've become a bit arrogant. So I took my new car that I managed to get a loan for, and I run a red light. I lose some points. I don't really apologize for it. I don't care. I start saying that the police is corrupted anyways. I start spending all my money from my promotion, and I don't care about my grandparents anymore. And then I cheat on online games. I've lost points. And then I came from being a really good citizen with a lot of benefits to becoming more problematic. So I get restricted access to license and permits. I maybe get excluded from certain planes and high-speed trains. No access to private school. I don't get access to the same public services as other people. I don't get the same employment, so then I get fired. I get a slower internet connection, for example. Once again, I put a disclaimer. This is not something that's in place today in China-wide. There's been a few pilots in different cities where it's gone more or less successfully, where they had to also roll back. And I think as of today, it's mostly a benefit system that is in place in China. It's not like that, but it's to showcase what can we do when a government gets access to so much data. So the goal was to get this objective score. How can we rate a human on finances and social aspects? And the problem comes from how much data are we gathering on someone? And a punishment system, is it really ethical or not? And what is an untrustworthy person, for example? And what happens is when a government gets this sort of power on its citizen, you get no freedom, basically. You lose the right for a private life. And technological objectivity as a way to basically guarantee that everyone's welfare is respected and that the system is fair, it's really hard to prove because often we will see that what is a bad action online? What is someone that's unreliable? Is it someone that disagrees with you, or is it someone that really is a bad person? That's where the problem comes. It's when you have an autocratic government that gets to basically pick and choose who they can punish. So yeah, after really getting the mood up about how technology is amazing and we're all going to be saving the world, I want to talk a bit about the positives. And I want to start with a few systems that have been already implemented that are showing some success or promising some success. I don't know if any of you has heard about M-Pesa. It's a system that's been implemented in Africa, and today it's their biggest fintech. And basically, it's for people who don't have bank accounts to get access to the advantages of a bank account through their phone and through just a normal phone system. You don't need a smartphone. It's not an app. It's really just guaranteeing access to banking for people who are underprivileged. So today, there's more than 52 million people using it. If you have had the chance to travel around Central Africa, you will see, that's where it's the most popular. You will see a lot of bars showing M-Pesa, a bit the same way as we have with Vips, but in even lighter version. And then you have, for example, the HOT system, which is when we have a natural catastrophe. It enables a mapping of the region. Where has it happened? Where have the first responders been? Where has there been no contact with the people? Where should we act? How do we prioritize? Where do we send the ambulances and the firefighters? That's also a very good use case for technology. And then the last one, which is the Ocean Cleanup Project, still struggling a bit to deliver results, but the logic behind it is interesting. And so basically, the goal of this initiative is to model the currents in the Pacific to see where they bring the trash in one location and then harvest this trash in a more efficient way. The goal is to have 90% of the trash out of the ocean by 2040. They're struggling a bit because their rigs keep breaking and they have had problems. Basically, it costs a lot of money to put the boats on the water and they have some technical issues. But the idea behind it, to get to use data in that way and model it is really, really interesting. And then there's other ways we can use technology. I want to talk a bit about precision agriculture. I don't know exactly how the hackathon works, but like that's also a super interesting subject for anyone who wants to work with it. So basically, how do we get the data? How do we optimize how we use our fertilizers? How do we optimize the use of water? How do we basically pick the right information and make a solid action out of it? And then we have another use case, for example, which is around governance. I just wanted to show that we really technology can have an influence on all three aspects. And there is, for example, for public procurement processes in countries where administration, who are the third party and / client in these cases, are struggling to stay struggling against corruption. And here the concept is basically to have the contract and the whole procurement process uploaded on the blockchain. Because if you have it on the blockchain, all the advantages of the blockchain apply to this contract. You get the security, and you get the fact that it's distributed to everyone. Everyone has access to the same contract. There's one source of truth. There's an immutability. There's no one who can try to influence or change the parameters that you have on the contract. And you don't require to put your trust in anyone. You don't require to go to a civil servant and say, you're going to be the one in charge of this contract, because that often can lead to some bribery requests and so on. So, oh yeah, there's a last one. And this one is very actual, actually, with the CSRD initiative at the moment. How do we get a good idea of a company's sustainability? So we have two types of data. The structural data, so that's your financial statements, that's your energy bill, that's where you buy your materials and so on. That you can sort of get an access to quite easily. And then there's all the unstructured data. What do people think of your company online? Is there people that think that your company has been behaving badly related to sustainability and so on? And there you can use natural language processing, which is very similar to ChatGPT, for example. Harvest all that data and bring it into a formal manner in a report that can enhance basically your ESG reporting. So it's really hard. If I could hire 3 interns and say, let's just go on Twitter, type the company name and try to summarize what people think about us. It's really complicated. With NLP, you basically get to do it in an automated way. And this report on unstructured data, it really brings a sort of flavor to what you're getting through your structured one. So yeah, lots of things, lots of ideas. I've only brushed a few ones, but there's a lot to do on sustainability with technology. lots of really great things coming. So I really hope that it helps a bit, inspire you, get some good ideas for what you want to solve in the next day. And if you have any questions, the floor is yours.
Cool. So we'll go to Marion now, and then QA after that.
Yes.
But thank you so much. That was a great introduction to many, many areas which are pretty important. So, Marion.
Thank you. I'm going to take a more positive approach. I mean, I could talk about AI a lot and about all the barriers in AI and the energy consumption of it. But I really want to inspire you into doing something positive with it. Because AI is everywhere, and it's becoming the thing that's going to change the world in the future. But actually, you can do a lot about with AI now that can help you empower real people to make better choices, more sustainable choices, by giving them access to data. So I want you to be grounded in the now and not in the future, where it will be all the AI agents doing all the decisions for you and for everyone, but more, how can you make good decisions today and empower other people to make good decisions today. I'm Marion, and I work as an engineering manager and product manager at Schibsted Marketplaces. You might not know Schibsted Marketplaces, but you might know Finn. So basically, it's a group of marketplaces in the Nordics. And today, I will illustrate how my team and I have been working with AI to double the amount of people that can understand pricing in mobility. There. Let me see. Okay, I see something different on the screen than you are seeing on the screen. So, all right, I will just put everything up there. It doesn't matter. So Schibsted Marketplaces is on a mission. And now I don't see my speaker's note anymore, but we'll manage. So Schibsted Marketplaces is on a mission to make sustainable alternatives the obvious choice. And we want to do that by empowering people to make smarter choices for themselves in 4 different areas. So we work with job, and in job we want people to give equal opportunity for finding a job to everyone. And then we have real estate, and we want to give people opportunity to find a home that is suitable for their need at all stages of life. And then re-commerce, probably a lot of you might have been using the re-commerce part, where we want to power the reuse of all goods. And then we have mobility. It's where we want to provide different type of alternative for mobility and more sustainable ones. So let's see now if it works. There. No, it's working. I think so. I work in mobility, and what we would like to do is to... what I haven't said is that we believe that the biggest impact that we can have is through our user behavior. We are driving sustainable behavior. That's what we want. So in mobility, we want to help people being more sustainable in the mobility choices that they take. And we have been playing with different models. So we have had like ownership models with a subscription. It was Honk. It got closed down because the market was not ready for it. We also have been thinking about, differentiating the price when you try to sell a car, if it's more sustainable or not. So we CO2 emission data. And there too, the market is not ready for it, so we're not doing it. But we have one place where we have managed to get some success. And it's to be transparent about how to do a vehicle appraisal and make that knowledge accessible to many more people than before. Because selling or buying a car is quite an unfamiliar context for many. If you have a car, you might sell it every 3 years. That's the average. And then when you are buying or selling a car, it's quite a high transaction. It's if you think about material transaction that you do, the biggest transaction will be your home, and then the next one will be your car. So the stakes are a bit high. So here is level of proficiency in numeracy in Norway. And there is nothing wrong about Norway. It's the same in all of Europe. But I have divided the population into three groups. You have people that are level 1 or below, and then level 2, and then level 3, 4, and 5. And what this means is that you have 18% of the population in Norway that can only get information from data if they are presented in a very simple way, like a percentage, for example. And then if you go to level 2, it's a little bit more complex. You might have a couple of more data points, and that is like 34% of your population. And finally, when you have a lot of complex data in a table or in a graph, you are going to only address 48% of your population. So basically, depending on how you present the data, you will make things more difficult. And actually, I think that was not my last slide deck, so it's not a problem. But what I want to illustrate here is that this is a complicated way of showing this data, and I can make it way more simple. I can tell you that this way, like everyone should get this slide. 1 in 2 doesn't get your information if it is more complex than a percentage. That is what was here. But as you see, here everyone gets it. Here it takes you a little bit more cognitive load to understand the full message. So if you can get your message from a graph or a lot of information into a very simple explanation, you will reach 82% of your population. That's way better than the rest that you were addressing before. All right. I also work with diversity, inclusion, and belonging, and I was working with a course at Schibsted. We made a course for to be more inclusive, and that's where I met Martin. He's the person behind me. He has visual impairment. He's totally blind, and we were discussing what we were doing. He's a developer, actually at Finn, and we were discussing our work, and I was telling him, I work with data and graphics, and I try to make insights, helping people to take insightful decisions. And I asked him, but when is the last time you saw a graph? Because he was not born blind; he became blind later. And I was like, I haven't seen or heard a graph since I became blind, because if you think about it, how would you read a graph to someone? Because they use text reader, right, to get this information. Well, you will read every data point, so maybe a couple of them. So to imagine a picture of a graphic in your head is really difficult. Same thing if you have a big table. Which part of the table are you going to read? Are you going to read all the data points? This is way too much for someone to grasp. So Martin is not an isolated case. There is 180,000 people in Norway that have some visual impairment, and all of us will have some problems when we get older. So it's also a group that is important to think about when we talk about accessibility to data. So when ChatGPT came along, I really saw an opportunity to make the data available to people. And I will show you how we did it. So here we're going to appraise a car. So you will start by typing in a registration number. No, it did not work. Okay, there should be a video, and it's not working. But basically, I'm going to tell you what happened. So you type in your plate registration number, you put your mileage, because the mileage has a big impact on the price of a car. And then we build a page called Price Tips that you can check out after. It's free to use, where you will get a lot of information. So you will get the price, you will get a benchmark. And in that benchmark, you will get a price distribution. So how have the other cars that are very similar to yours have been sold on the marketplace. So you will have, it's a histogram. And then you will have the same with the mileage, because as I said, mileage is very important. So if your car has a lot of mileage on it, it will be the price that we think you should sell your car for should go below the other ones. So we kind of get you to that, and then to explain that graphic, we have made an implementation of ChatGPT, where we put in a lot of information. That's the yellow part here. That's all information that is contained in the web page, and we have a role where we explain what we want the bot to do, and then it gives you an information in plain text that everyone can hear with a text reader, and with a very much simpler way of showing it, right? In the right context. So we are taking something that was at least at level 3 to something that is at level 2. I'm not claiming it's at level 1 because it's still a very complex context and people don't know all about it, but I think it's really getting the barrier lower. And of course, we could also simplify it with simple text and so on. But that's our first implementation of it. And why does it matter? Well, it matters because you cannot force or push anyone to change. People will just change when they want, they need, or they are ready for it. And it needs to come from intrinsic motivation. They want to change because they are the kind of person that does this kind of good behavior. They're not going to do it because you well, you pay for them for it, right? They're not going to do it. I mean, they can do it once, but in the long run, they're not going to do it. So you really need to make them want the change. So what I think you should be doing during the hackathon is really focus on providing accessible information that can motivate for a change of behavior. So in summary, AI offers a great opportunity to include more people in the change by providing everyone with the information they need to shift behavior. And that's something that you can build right now. What we built here, we did in one day. We had a hack day at work, and we just did that in one day. So it's possible to do this kind of stuff. And for me, if I was staying, I would be working on making this whole page of insight, and not just these 2 little graphics, but the whole of it into an executive summary. So that would be even easier for people to get. So yeah, I wish you have a good hackathon.
Cool. Thank you very much. If you stay where you are, because we're going to do a Q&A with you and Antoine. Yeah. So we're going to do a very short Q&A. If you have any questions that you want to ask either of them, and then we'll take a very short break, like 5 minutes, just so you can get some air, and then we'll carry on with the other speakers. They're exciting. So cool. Does anyone have any questions that you want to ask either of these people? I don't know if that one works. No questions at all? Yeah.
Okay, so this is a question for Schibsted.
All right.
I was just wondering, I think there's a large difference between the 200,000 and 400 for the car. How do you know what the car is actually sold for?
Yeah, so we don't always know. We have a service that is called SMIDI Bilandel, and there people, so we know the price the car is sold for. The model that we train because it's a lot of AI, right? The AI is also for modeling the price of the car. So we take the last advertised price. So we we advise on what should be your listed price. So where you should go at for. And we use the last price people decrease the price to, because a lot of people decrease the price. So we don't start with the top price. So it's closer to what we believe the car has been sold for. And then we also know, we have a control group with about what the real price on those transactions that we control are sold for.
Okay, cool. Thank you.
You're welcome.
Thank you. Yeah. I had two questions from both.
Okay.
From the first Antonio. Yeah. So the
Good
first question was that when a new technology comes up, my personal question is that why the companies hypes it up a lot and sees the other people doing that in a wrong way, or like interpreted in a different way than what they do. So for example, when we talk about blockchain, we focus on Bitcoin and how much it's producing carbon dioxide. But when it comes to I feel like you're working in a company that's high tech company.
Yeah.
So, but when it comes to our own work, we like to have the contracts on blockchain platform. So this is one question, that why companies like see themselves what they do as what it is better than what it was in other companies or platforms.
So what you're saying is, on blockchain, we talk about cryptocurrency, which has this negative impact. And then our companies, like, we work on building sort of like contracts that are on the blockchain, which is a good thing. And you want to know why, like, what is the...
Yeah, for example, the question is that why AI, for example, we see AI as a threat sometimes, but when it comes to ourselves, we see AI as a good thing, as advantage.
Yeah, I think it all comes down to, I think, capitalism first. You will, when a new technology comes, the thing that will most often happen is that there is no regulation for it. And you will have no legal framework. And so when it just exists in this ecosystem, you will have some good applications of it, and you will have some applications that will lead to some problems. And then the regulation follows up when they realize that, maybe this is going out of control. We have to sort of like frame it. But it's very hard to make a regulation before understanding where the technology is going. AI is really a wild animal. It can be great when people like Marion are around it, and it can be awful when other people are doing it. If I'm becoming like the devil's lawyer, I will say that when I show the bad examples of AI, it's also part of the innovation process. Suddenly we understand that it's super important to have a diverse data set. You don't know that until you've tried it. So it's a new technology will go in any direction the humans around it will take it. And can be wonderful, and it can be really bad. And then if it's really bad, we have to fix it. And when it's wonderful, we should just let it go.
I'm going to have a take on it on AI as well, because I actually have a PhD. I work with ML, so I had a PhD with ML, and now we have generative AI, right, which is a new hype. But you have had AI for 25 years, right? And like big data was the first wave of AI, and where you got like the recommendation engine on Netflix, for example, this kind of tools. And you got a lot of models of predicting already, like the loan things. That's an old kind of thing. The new stuff, Gen AI, it's more about what is, as every technology, and now I'm going to be a bit, I'm going to be a little bit going out of what I should be saying, but I mean, all technology has been used in porn, right? What is the Gen AI application to that? What is deepfake, right? And that's the first application that you have had in AI, and that's crazy. But of course, you have also a lot of good things in AI and a lot of possibility. But there is so many aspects with AI that is either good or bad. And right now, very little regulation is a problem. But I think you are getting the same problem that you were having before, which was the data. Like everything you do with AI is about data, which data you have inside, And you showed some really good cases with discrimination on color of color. But you have yeah, so it's all about the bias and how you should be regulating and looking at them. And that's why like the application I showed is really safe, because you are in control of the data that you are putting into it. It's called RAG. It's now a retrieved augmented generation. So you have 3 places where you can put data in, or you control what the result of your AI will be. It's your scripting, like your prompting, what you ask the AI to do, and the limit that you put. There's some bad application of it as well. I mean, I've seen Gemini when they ask the AI to always be nice and show diversity. Well, then you had picture of the founder of the United States, and all of them were colored, which was kind of not really true. So you have the prompting on how you kind of write your prompt, and you have to kind of balance it with like history and everything. And then you have like where you can put your data set that you choose to train your model on it. There too, you have to kind of set a boundary for what you can be using it for. I mean, if you know that the color of the skin is already white, then you have to do one data set for white people and one for black people. That's just how you should be doing it. And then the third one is when you can input the data into the model.
Cool. So just for time, we gotta stop there. But you're reachable on LinkedIn.
Yeah, you can reach me on LinkedIn, and you can reach me on Discord.
And you are also reachable.
I'm reachable on Discord. I put it at the start of the presentation.
Yeah.
So you have it. And I'm on the group on the Discord.
Yeah. So if you're not a member already of the Techna Discord, we can figure it out later. But then you can ask him there. So cool. Thank you very much. And now we will take approximately a 6-minute break, just so you can get some fresh air, so we can have time for the remaining talks. We have some data sets from the UN coming up with the speaker who's in Florida right now. So they'll be calling in. So that's exciting. We also have one who's also calling in about sustainable data centers, and one about construction, and one about undersea mapping or something like that, I think. He can explain later. But yeah, cool. You have 5 minutes now. Sorry, I talked for 1 minute. Try to be in here 18:05. Thank you. Hello. Okay. If you can start going to your seats, we're about to start up again. Please find your seats. Okay, welcome back. Welcome back. So the next two speakers we have now, they're online, and one is joining from Florida, and one is joining from not Florida. So, Anna, are you there? And Colleen?
Yep,
Yeah.
I'm here.
Yeah, I'm here. Yeah, nice to
Okay.
be here.
Welcome, and go ahead.
Thank you. Okay, so I'm so happy to be here. I'm software developer and board leader of Forum for Technology and Development Cooperation. And we are an association of volunteers. We are loosely connected to Tekna. I'm sorry, I get a bit embarrassed of seeing myself in a few seconds later. Could you please drop that? Is it possible? Or can I take a look at my own? Yeah, thanks. Thanks a lot. Okay. There. Okay, so the content for my talk will be the UN SDGs. You already know a lot of these, and how to measure them, the UN indicator database, and also a regression tutorial in Python on the SDG indicator time series. So I've written a lot of code, and you can just use it as inspiration for your work tomorrow. So FTU, we are working for reaching the SDGs with use of technology and also global perspective. So you can take a look on these slides later on. We have a lot of activities. So we work with AI for sustainability. Is it a benefit or risk? And how to decrease energy use in data centers. And we also have an open innovation project together with Norwegian People's Aid. So it's so interesting. A pilot country will be Ukraine to remove pollution after mine clearance and after war. We need more volunteers. So if you want to help us organize some events or help us with minor tasks, please contact me. So now it's about the SDGs. They were set in 2015, and they will be reached by 2030. And how to measure the process of reaching them? It's very, very difficult to measure. So 2 years after they agreed on the SDGs, the UN agreed on the indicator. So they found 231 unique indicators to measure the process of the SDGs. And these are in an indicator database. Anyone can download the data. So it's a bit difficult to understand how to find the data and the right data and so on. So I made a tutorial, and it's on my slides. So if you are inspired by my talk, you need my slides. So first you choose the SDG analytics, and then in the upper left corner you choose your option. And it's possible, as you see here in the lower right corner, to download a CSV file. And when you do that, you can see graphics that are generated in this user interface. So here I chose a summary of all SDGs in the whole world, global summary. And as you can see here, take a look at each SDG. Number 7 is almost completely green. So everything's perfect with number 7. So we will take a closer look on number 7. Everything is fantastic with affordable and clean energy. Okay? Do you believe that? And at the same time, if you use other sources of data, you can find that global coal consumption is still increasing. So it's a lot to do with SDG indicator data. It could also be interesting to check separate results from large countries here. So everything is fine for very famous countries. So why is it that? And there are also some other interesting results. Some SDGs are almost completely red. And everything is 0% progress. Why is it like that? It seems like almost no country measure goal 5, 12, and 16. Is that true? Okay. So it also exists an API for being able to call the data. So I've made another tutorial on how to use it. So the first thing is very important. There exist 2 versions, and the latest version I put the link on this slide and also in the references, the last slide. So to be able to use the data in the API, at first you need to know the number of the area and the country you need to work with. So here's the code for that. And to be able to understand the response is very useful to choose execute in the Swagger UI. And always inspect the indentation of the response in the Swagger UI, because it's nested in so many layers, so it's very difficult to understand the structure of the data. And here is code for getting time series. And of course you can study all possible time series, these 231 indicators, or you can just see them in the UI for the database. And the documentation isn't very good, so I actually emailed the statistics division in the UN, and they actually answered me. So they sent me this series to study. They wanted us to study this series with area code 8 and series code VCHTF-DETV. And it turns out that this is trafficking data for Albania and for children. So it's rather heavy stuff, but it's very interesting mathematically and programming. So this code on the last page are able to compute the total sum of children who are victims of trafficking in Albania from 2008 to 2014. So the data from 2015 and further on is lacking. And it could be interesting to take a look on how about the trends in the data. Why did they stop telling how many victims? So I have further investigated the trends in the data with NumPy, matplotlib, and scikit-learn. So at first, you have to create NumPy arrays. They are used for plotting, and they are used for machine learning in scikit-learn. So I do this here. This is, I have grouped the data because there are several instances of data for each year. So I've grouped them on year. And it's possible to group on year in shorter code lines, but this is more easy to understand. So with the NumPy arrays, I also get the same result. So the code is working. And if we plot these NumPy arrays with data for each year, we can see that there was a trend, increasing trend of victims before they stopped telling the number of victims. So, and what could also be interesting is to use some machine learning algorithms for detecting the trends and patterns in the data. And so I did that further here. And it also will be interesting for you to see because Colleen, she will talk on more technical stuff related to this regression in space. So here I used the linear regression module, but I used a third-degree polynomial. So you can just take a look at some tutorials on why I use linear regression with higher degree polynomials, but it's possible to understand. And here we can see that my third-degree polynomial fits rather well with the data, and the trend was increasing when I stopped counting the victims. So I will give a short introduction to Colleen's talk, because what you have seen I did now was one country and one time series. And if we would like to see how behavior spreads across borders of countries, we can create graphs of connections of countries. So, and Colleen will talk a lot about that. And I have included a very interesting part of a tutorial on how to create a neighborhood matrix. And Colleen is using that kind of matrix in her code. It's called a weight matrix. And you can see it's a square down in the right corner. It's with ones and zeros. And it's a symmetrical matrix because, as you see, it's symmetrical around the diagonal. And that's because one means that the countries are connected. So if Sweden is connected to Norway, Norway is also connected to Sweden. So if you would like to see how the behavior of the SDG indicators is spreading across borders of connected countries, you can yourself create this weight matrix, as you can see here in this slide. But Colleen will talk much more about that later. So here are some tasks I have made for you. The first two are easier, and third is of medium difficulty, and the fourth is rather difficult. Okay, here are references. So you can also see my code on GitHub if you would like to use it. Okay, thank you very much.
Cool. So we'll jump straight over to Colleen, if you are there.
Yep, I'm here. I'm going to share my screen now. Hopefully everything works. Florida had a lot of hurricanes lately, so things are pretty slow to load. So thank you for having me. I'm going to go over a little bit about data that varies by space and time, which is going to be common in the data sets that you're working with. So there are a lot of tricky things with spatiotemporal data that varies by space and by time. It has a spatial component, so there are dependencies across geographies that are connected by common factors like a border or a trade agreement that are going to impact the outcome. So trade agreements, pricing for food and goods are impacted by tariffs. Weather patterns in adjacent countries will impact the countries next to them, and just in general, anything that's connected generally isn't independent, as a lot of methods assume. But we can get around this using the local Moran statistic to weight a metric by this connection matrix that Anna mentioned briefly, that you can create to show which countries are connected to each other. And this can be used to impute missing values. So say, you know, what Denmark and Sweden and Norway have as some of their indicators. Countries nearby probably have similar values. If all of the countries kind of in Scandinavia are acting the same way, we can impute any missing values there with a good guess of what might actually exist as that value if it had been measured. This is impacted by the choice of metric. Generally, we have a correlation. So if we're looking at prices or behavior rates in different countries, we can create correlations between those countries. We can also measure the distance between indicators. So if you have binary data where things either exist or they don't exist, you can calculate the overall Hamming distance of how much two countries differ on that series of indicators. And this gives us a good way of understanding what's going on between the countries. And this weight matrix, this connection between countries, adjusts the metric so that countries that are next to each other or have trade agreements or any other factor that might be impacting your outcome are weighted more closely to each other than longer distance connections. So you can use ones and zeros, or you can use more of a gradation of 1, 0.5, and 0 as weights to kind of denote your distances between trade or your distances between borders that will adjust these correlations for geography. The time component also has dependencies. So buying behavior is dependent on prior buying behavior. Policies impacting the price of goods generally have long-term impacts. If there's a tariff that came in place, it's not just going to impact one day of pricing or one day of sales. It's going to have long-term impacts. And we also have seasonality trends. So Christmas sales or summer sales, there's going to be different buying behavior or different human behavior depending on the season. But we can use autocorrelation and overlapped windowing to account for dependencies. Essentially, you look at correlations over time and you can chunk this into different time blocks. There are some models that deal with these dependencies simply through correlation, like an ARIMA model, or the polynomial regression that you saw earlier. Or you can window and chunk the time series into overlapping time periods. Maybe you want to chunk by week and look at overlap across a weekend to kind of knit the data together. There's a lot of statistical techniques that have already been developed that do these types of modeling of your data. Spatiotemporal regression is one of these. It accounts for these correlations over space and these correlations over time. And there are a lot of different varieties of these. You can have classical or Bayesian versions. You can have general additive modeling, and a lot of these extensions of regression have spatiotemporal flavors of your regression algorithm. However, it's very computationally intensive and you need a lot of data to do this. Structural equation modeling is one way of handling this within a regression framework. You can capture the time and space components with regressions that feed into each other. But this is also very computationally intensive and requires very large sample sizes with very little missing data. However, graph-based approaches are a lot more flexible. There are graph-based approaches that fit into a regression framework. So you can look at global graph summary statistics at each time point or in overlapped windows of time, such as the diameter or radius of the graph, which measures potential spread. So if you're looking at behavior or fake news, looking at the diameter or radius of your country or group of countries lets you know the potential for spread. You can also look at spectral properties related to connectedness through the Laplacian. So these have deep connections to spread again, as well as the underlying geometry of your system. And what these statistics basically do is give you information about the system at that point of time, which can then be fed into a regression model or a polynomial model to reduce the number of variables that you're looking at and kind of aggregate all of your information about connectivity together within the context of whatever outcome you're looking at. You can also do this locally at each country. So each country would be a vertex that are connected by borders or by trade agreements or any other connections that you can think of that would connect countries together. And this can also be looked at for each time point or for some overlapped window that combines time points together. A lot of the well-known ways of doing this are to look at the centrality of vertices, so how important they are to hubs where lots of connections exist. So maybe NATO countries, if you're looking at something with trade, you might want to look at NATO, and you're going to have these very large clusters of countries that all have these mutual agreements with each other, and they're going to come out as very important within, maybe we're looking at all of Europe, having those connections is probably going to weight those countries a lot more in connectivity. There's another type of centrality called betweenness centrality that basically measures how well a certain country would connect other countries. So you might have a lot of your finance going through Switzerland, and Switzerland acts as a connector between different areas with trade agreements or other connections, regional connections or something like that. A more advanced form of centrality measures the curvature of vertices or edges. And this is basically measuring how much the connections between countries are kind of warping and weighting specific areas of the graph. This has been used a lot with combating misinformation. Generally, within misinformation or epidemic spread, if you have very high curvature in an area, you're at high risk for spreading. And any of these can be used as metrics within your local Moran statistics that allow you to use a pretty basic statistical model or one of these spatiotemporal regression models. So those are good graph-based approaches. We can also look at change point detection, so looking at changes in behavior over space and time. So we might want to predict unaffordability of food in regions, pinpoint stock market crashes early enough to be able to correct the market, or understand tipping points in epidemics. And generally, one of the really good methods for doing this is looking at how the Foreman-Ricci curvature changes over time or geography to see how much things are changing in that area of the network. So we're going to go to Python and look at one example of this from my book, Modern Graph Theory Algorithms in Python, which has all of the code and data available open source. So I'll switch over to here. Can you still see my screen? Hopefully.
Yes, we do. Yeah.
Okay. So the link in the PowerPoint, and I can make this publicly available, my PowerPoint, but at the bottom, you see the data file and the files that we're going to be using, the millet data and the weight file for the millet data are both included here. And I think this is chapter 7. Yeah. So chapter 7, script 1 shows an example of this. You may have to install some packages, and I prefer using iGraph when I'm working with graph data because it's very flexible and easy to write your own functions. So we can first import the data set that has our pricing for millet across provinces in Burkina Faso. And then the weight matrix, I created this so that provinces that are connected by borders are connected within this weight matrix so that we can parse out geographic areas. And then I look at yearly sets with 3/4 overlaps. So we have quarterly prices. We window the time period so that the window is a year and there's substantial overlap. So there's a unique quarter in each of the time periods that we're looking at. You may want to have less overlap, but here prices are pretty correlated over time, and being able to capture those dependencies tends to work very well. So first we parse our data into a time period, which is this line right here, and then we find the correlation coefficient, have our weight matrix and threshold of correlation. You can do it without a threshold, but generally it makes the math a lot easier to follow if you pick a correlation where you think it's sufficiently correlated to be meaningful in your data, multiply that out by the weight matrix, and then create a graph out of the adjacency matrix created with this weighted correlation. And then from there, we take out the self loops in this piece of the code so that nothing is self-connected. And then in this code, we have a few different things that we're looking at metric-wise. So we have our degree that's going to be captured by time point, our page rank by time point that we capture and append to our time series, and then we calculate the Foreman-Ritchie curvature in this last piece here, which basically looks edge by edge of the vertices connected to that specific edge, and looking at their how they're connected to other vertices in the graph by other edges. So basically like how much the graph is being weighed down. And then we sum up the edges for each vertex that connect to that vertex to get a measurement of curvature. So when we look at this across time, we can see that we have more and more negative Foreman-Ritchie curvature over time. We don't see much change with the page rank. But when we plot this, we can see that things are kind of cyclical in how they're connecting, but the trend is that things are more and more negative, which suggests that they're more and more connected and more weighed down over time. So this can be helpful for looking at tipping points and changes in behavior when you see the graph change dramatically from higher values to lower values or lower values to higher values, basically you can see that something is going on in your system that's driving a different pattern of behavior. And here, somewhere around here is when COVID happened and the prices started correlating very well and getting to be unaffordable for a lot of people. So it's pretty useful to be able to see kind of the system vulnerability over time. That is all I have. So thank you.
Hello. Hello. Cool. Thank you very much. Now we have Petter. Are you there?
Yeah, I'm here.
Okay, all yours.
Can you hear me?
Yes.
I'm sharing slides as well. And then I guess you can see them. Thank you for the invitation. I'm Petter Røkke. I'm from a day-to-day basis. I'm a research director in SINTEF Energy Research on a department called Thermal Energy. So, which then in essence means heat. And what have I been working with of relevance here on a quite different perspective than the previous speakers? The energy systems and also the utilization of waste heat from industrial processes such as data centers. So when I talk about sustainability in data centers, this is mainly related to the energy use, energy consumption, and also how it is actually, well, you can say wasted after the processing within a data center. And I'm also using this one picture here, which can provoke ICT people saying that energy-wise, what is a data center? And what you see a picture of here is what is like the most commonly used heating source in Norwegian households, a panel oven, electric heater, you can say it. And I was once actually on the daily news, the main news here in Norway, being quoted here on saying that a data center is basically just a gigantic electric heater, underlined energy-wise, where all the electricity is converted to heat. So in that essence, using energy for a data center is a lot of electricity going in, as I'll show on the next slide here, lots of electricity going in, and in essence that is either used for data processing, i.e. also generating heat, or it is used for the cooling system, which then also generates heat or waste heat is coming out of the process. Only just a small part related to like lighting and auxiliary devices here. So when talking about waste heat, the first thing I would like you to say is that please redefine it towards saying that it is surplus heat rather than waste heat. And by that, being sure that this is actually a resource that can be available for the energy system if it is utilized. So defining surplus heat, making it available. If you say waste heat, it's wasted, so it's not useful for anything. And a bit about the energy consumption that has also been commented by other speakers. The forecast of data centers and how much energy will be used by this is shown to the left here as an example, increasing exponentially over the coming years. And this was also pointed out by other speakers. And on the global like internet traffic also on the figure to the right, how this actually will increase over the coming years is huge. I mean, this is much more than anything else that has happened before on this planet. And this amount of energy consumption that this digitalization, AI, and so on will actually, what that will actually demand is more than anything that we've been facing before on the planet. So talking about sustainability in digitalization and for data center is of big importance. And more specifically, the use of artificial intelligence, and there's a lot of sources. I found this or been using this chronicle in Forbes, focusing on AI processing and the increase of that as well. And you see that the figure to the left is for the coming few years up to 2027. Estimating the global data center power use will be tripling this year, and that's from 23 to 24. Whereas for the coming years, increasing further to exponential values, you could say, compared to these years. And to the right, particularly related to the artificial intelligence processing, and the power demand for that, like this demand to surge 550% by 2026, from 8 terawatt hours in 2024 to 52 terawatt hours in 2026, which is extraordinary. And that is also a picture showing that the use of data power for new purposes, an important purpose like artificial intelligence, which will certainly make the society more efficient. It will help us from day-to-day basis, but this also shows that it will require huge amounts of energy. So when it comes to sustainability, utilizing the surplus and waste heat from a data center, if you have like the typical cooling technologies being used for data center today is by air cooling, and by cooling the data processors, typically have surplus heat coming out of the system in the range of 15 to 45 degrees C, which is then like, okay, it feels good if you're sitting there, it keeps you hot, but this is also a resource which can be made available if you upgrade it by, for instance, using a heat pump, and this can go into like a district heating system. And this table here shows the different applications that such surplus heat from a data center, what this can actually be used for. But there are alternative technologies to actually cool data centers, like water cooling or two-phase cooling, which is more novel, where you can have higher temperatures of the surplus heat coming out of the system. And why am I aiming for that? Because at higher temperatures, there are obviously more purposes or more applications for the surplus heat that can create values for other industries, for households, and for us as a society. And I've always been like raised, the question has been raised, what can such low temperatures actually be used for if it's like 30 degrees C? And I've been using these examples. It's for like greenhouses where you're growing tomatoes, fruits, or vegetables. These typically need like a airflow through it and making it warmer so they can grow faster. And you're not trying to boil the fruit or anything like that, just to make them grow faster. And down to the left, there's like a seaweed. If you're drying seaweed, seaweed has carbon as a resource that can be utilized, for instance, for biofuel production or other purposes. So that's like sustainable carbon can actually be produced by seaweed, but obviously it's quite wet, so you need to dry it. Surplus heat can be used for that. And just to mention, which seems a bit far off, I'll also have a snowblower here. On a picture up to the right. And why do I have that? Because those types of snowblowers are painted with a type of very special paint that needs to be dried when it's wet, and then you typically need airflow at 25 to 30 degrees. So those are some applications for such surplus heat at that type of temperature range as examples. But these amounts of energy, I mean, given that the energy input to a data center is converted to heat, and the amount of energy being needed for data centers, it will be. I mean, you can just start doing the calculations of how many greenhouses can you actually have for that purpose. So it's quite a bit. So I have these three steps that I like to point out for data centers to make them more sustainable. And one is then technology, as I talked about, going towards like fluid-based cooling solutions, water or two-phase, and then to have a collaboration with the potential users of these low-temperature heat from data centers that can increase the efficiency of a society if you can actually utilize that heat. And then, of course, it's the location. Heat is local. I mean, electricity you can transport over a long range, whereas heat is not that efficient to transport over long range. So they should be located in the vicinity of the potential heat users. And then, of course, like the early phase planning together with who can use the district heating or food production, as I talked about. And of course, not to put these in untouched air nature, but rather at so-called gray areas. One thing that can also make it more efficient is to have like the servers in a data center more compressed, more compact built, and then also by that also having higher temperatures that can be utilized. So summarized the same points to the right in a bit more graphical way. And I'm just including this figure here as like a build up to the final slide from my side, is that can be integrated into the future of the integrated energy system, where you can utilize this heat for energy purposes or heating purposes in urban areas. If you can do that, you can actually free electricity, which is then today used as heating source in urban areas. So using electricity for data centers and then utilizing the heat, and then you can actually free the electricity that you're using to develop or to process the data within a data center. I hope you can understand the picture there, but that would actually increase the sustainability to more like 100% when it comes to the energy being used for data processing. To the left, I have like a link where the more like very simple way of looking into how the different industry sectors can collaborate. We have produced one of these handbooks. So if you search for HIF, the logo down to the right there on the picture, and handbook, you can find that one. It's like a 8 to 10 pages document, very simple aspects of how to increase the resource and energy collaborations between industries. For this pitch, I was challenged if there are some problems that I suggest that you can talk about, and then please have in mind this is ideas from Dinosaur when it comes to coding and hackathon and so on, which is then me. So apologize if this is like a very simple problems, but then I'm eager to sort of look into or what you can come up with when it comes to the energy demand and how the data center can be integrated into energy system, given the variability of the energy sources with a higher share of renewable energy coming into the system. The different energy carriers, the low demand within the data center, energy storage, and so on. And also how that can improve the decision-making for authorities when it comes to realizing digitalization as an enabler for improved industrial and public processes. And the last one, and how can you actually ensure that this is implemented as sustainable as possible, given the definition which was also raised by the first speakers today on the economical, environmental, and social aspects. So I hope that I can actually frame this, the work that you're doing into also something that can address the sustainability when it comes to the energy of data centers. So that is from my side. Thank you for the attention, and I'm sorry, I'm a bit of a dinosaur, so I'm not into Discord, so we'll need to either contact me by email or LinkedIn to follow up on this. And you have the QR code for my LinkedIn profile there if you want to contact me. So thank you.
Cool, thank you. Okay, we'll go straight into Vitalis. Welcome.
Thank you. Now it's turn for next dinosaur. My name is Vitalis. I work in Stadsbygg, work with the responsible for R&D activities in Stadsbygg. I represent today construction sector, and you've seen this before and heard and thought maybe before, like, come on, it's so outdated and conservative branch. What this guy is doing here? I'm going to explain more about this. First about Stadsbygg. Maybe not everybody familiar with Stadsbygg, but I'm sure everybody have seen our buildings, and many of you have been inside of our buildings. We own buildings on behalf of Norwegian state, and we own buildings with the special value to Norway, to the country. Buildings like Opera House, National Museum, Royal Palaces, university campuses, prisons, maybe not relevant for everybody here. So I would like to speak about construction industry. It have been discussed a lot that construction industry has a lot of problems. And probably we have even mindset problems and some other problems. And indeed, we do have problems. We have a lot of problems. We see from productivity. Productivity in construction industry has improved only by 10% during last 20 years. At the same time, if we see on the global economy, the productivity improved by 50%. And if we just isolate the manufacturing sector, like industry, it's 90% improvement. So we are really behind. At the same time, there are a lot of challenges that the construction sector is going to face. It's first of all, it's a workforce decline towards 2040, and we notice already now that it's not so easy to find the qualified people that would like to work in the construction sector. At the same time, we have to double the production rate to meet demand for housing. And of course, as mentioned before, we are slow. When I say we, it's not that big. It's entire construction sector. Slow uptake of technologies, more focused on control, and especially control of costs. It's natural because building projects can cost a lot. Many projects, like called mega projects, they cost many billion of crowns and last over many years. So it's really high complexity. You have to be able to control in some way this complexity. Decreasing returns. It's really difficult to earn money, especially on complex projects globally. 44% of all the projects, construction projects, end in loss, and I guess, I'm not sure, but about 60% of mega projects also end in loss. The next challenge is environmental impact. Construction sector stands for a huge amount of environmental impact. This is, you can see the graph that shows CO2 emissions. It's about 40% of global CO2 emissions come from construction sector, and it's also, this graph also shows emissions from construction industry in Norway, and you see it's the largest contribution out of all other industries. On the global scale, construction sector stands for 23% of air pollution, 40% of drinking water contamination, and 50% of landfill waste. And in addition, on top of that, when we build a building, we destroy nature, of course, and we also destroy natural habitats for animals and insects. And the footprint from construction sector goes through entire value chain. We start with the material. Production of cement requires a lot of energy, a lot of water, and stands for a huge amount of CO2 emissions. And then we need to transport these materials first to some storage house, and then to a construction site. And then when you get the material on your construction site, then you have to cut it on site. And then we notice that, or we estimate that about 30% of new material, completely new material, just go directly to waste because of, how do you call it, AFCAP, you cut it. And when you are inside of the building, like now, you need electricity, you need heating, of course you need water. We need to provide this as well. And when we demolish the buildings, it's a huge amount of waste, and almost all waste go to landfill. And waste from building and construction is the largest source of waste in Norway, for example. It's 2 million tons per year. So we have a lot of challenges. We need to be more sustainable. We, construction, need to be more sustainable. Reduction of waste, reduction of transportation, reduction of energy use, reuse of building elements, and of course, smart energy exchange. It's smart. Let's say smart energy exchange. Should I round up? No. Okay. How digital solutions can contribute? By the way, Statsbygg is under Ministry of Digitalization. So the Norwegian state wants to show that the digitalization and construction goes hand in hand. A lot of areas for application of advanced digital solutions. It's like optimal design of buildings. For example, we can design buildings that can be used by different groups, like school at daytime and maybe cinema at evening, and maybe, I don't know, some other activities at nighttime. reuse of old elements. There is a new law that says that all new buildings should be designed and built in such a way that they should be ready for disassembly. So we shall not demolish buildings. We will disassemble buildings. But then you have to be smart and keep track of the old elements to be able to reuse these elements. So you design new building, but you have to have information how you design new building based on old reused elements. Project management. Imagine you are in charge of construction of opera house with the price like I think it was 4 billion crowns. And you have to keep track on economy and progress, and you have to be sure that you fit within your budget. Sometimes when you go to grocery store and buy some stuff, you buy more than you planned. So, and it is really simple operation. So think of a project with millions of different positions you have to buy in the right and put them in the right time and the right place, and a lot of subcontractors and a lot of stakeholders around. Logistics, a reduction of waste. We can be more smart and design buildings so that they do not need cut, for example, or reduce the amount of cut and waste. Logistic, just on time delivery. And then you save both on transportation, but also on storage. And sometimes you have to move the stuff many times from place to place. Building management. Modern buildings, they have a lot of sensors. You see the sensor is blinking there, and there are a lot of other sensors that help us to control the building, both electricity, heating, ventilation, everything you can imagine can be controlled now. But we can implement advanced systems like based on artificial intelligence and make it even more efficient. And of course, energy, local energy production. There is a requirement, a recent requirement that, for example, all state-owned buildings in Norway should have local energy production, and mainly it's solar power, of course. It works very nice in summer, but in winter, many problems. So I've told you just the framework, the context for construction. You're free to choose. You can pick up any topic you like. Waste reduction, for example, logistics or something like this. Or I can present the concrete case. This is Campus Evenstad. It's a small campus located like 2 hours drive north of Oslo. I recommend everybody to visit this site. It's really nice nature, and you can also learn about the campus. It's part of Høgskolen i Innlandet, 22 buildings, 10,000 square meters. We have installed everything that was possible at that time in this campus. We have photovoltaics. It was, when we installed it, it was the largest photovoltaic system in Norway during 10 days. And then another company installed even larger. We have solar heating here. And then we have also energy storage, huge batteries to store energy, electricity. This is heating. You have to keep in mind energy can be heating, thermal energy, and electrical energy. And then we have also installed vehicle to grid, two-way charging. So you can come with your car and we can use your energy while you are on campus, for example, and to balance the peaks. Some information about the concrete capacity and so on. And there is a website also. You can visit website. It's in Norwegian. Google Translate will help you. I just pick some data from sensors. Actually database is really huge. It's many hundreds of gigabytes. I was not able to export it, but I just took some samples. It's like 7,000 files, comma separated values. I pack it in archive. So you are IT guys, you will be even I dinosaur. I did this, so it's not a problem for you. The data shows energy consumption, power, and then battery use, and I guess also some temperature data. Yeah, our ambition is to achieve first a zero emission neighborhood, and then at least 75% of energy should come from local renewable sources. Per today, we achieve about maybe 50-60%. In some good days, we can, when there is sunny weather, we can run off-grid completely at the campus. But when it's cold and no sun, then we have to import energy from the grid. Probably you need some resources. I'm not sure. Temperature data. I have to run out. Yeah, I see. Yeah. Temperature data, some statistics on energy, for example, on solar radiation and other information probably you would need or would not need. Good luck. I will be able here to answer your questions, and then tomorrow also answer your questions, but it's better if you find me on LinkedIn. I'm also dinosaur, like the previous guy. That's all. Thank you.
Cool. Thank you very much. And then we'll go straight into the last talk. And then after that, we'll briefly tell you about the rest of the evening, but there is pizza waiting. So if you're hungry, you just know. The next one is with Ehsan. Are you there?
Yes, can you guys hear me?
Yes, perfect. Over to you.
All right, I'll just share. Right. Hi, everyone. My name is Ehsan, and today I'll be speaking to you about the data on the health of our ocean. Okay. We can go to the next slide. Yeah, sorry. Okay, so probably to a Norwegian audience, it's not really smart to have this slide, so you all know much more than the rest of the world, I guess, about the importance of the oceans and monitoring the oceans. But nevertheless, I thought it's important to emphasize how key of a role oceans play in our future, and to face the challenges that are caused by climate change, from the oxygen it provides to the carbon sink, the great carbon sink that the ocean is, to the regulation of the heat and many other things that probably you guys know all about and you've heard all about it. But so it is really important to have better monitoring of our ocean's health, and we need much more data for that. The way that we collect data so far, so we've been doing this for hundreds of years, sending giant vessels in the middle of the oceans to collect data that they need very expensive and huge kind of operation and instruments. So it's more both really expensive but also it's not sustainable. If you want 100 times, 1,000 times more data about from our oceans, this is not a sustainable way to go. So there are other instruments. You could basically throw these instruments in the ocean, and they would drift with the currents and maybe go up and down the water column and send you data, various types of data about the ocean. But at the end of their life, they're not really steerable, and they become basically part of the ocean the trash in the ocean. So this is also a great tool, but not really sustainable way to go. And towards the right, we come more towards the autonomous ways of monitoring the ocean, and that's through satellites, so remote sensing. But again, that's just gives us the top few centimeters of the oceans. Great data, great overall data in a big scale, but if you really want a small scale, and if you want depth data on the depth of the ocean, so profiles, you would need to actually go there with instruments. But there are instruments, there are autonomous instruments, such as these instruments that are driven by wind or by wave. But today I'll be focusing on these instruments called underwater gliders. So just a brief background of what underwater gliders are. As the name suggests, they're basically glide in the water. So there's no engine, there's no external moving part. Essentially, there are two. So this is their the way they go forward is by going up and down. And by so to do that, they need to change their density with respect to that of water. So to achieve that, you have essentially two reservoirs in the gliders that oil is pumped in and out. This way, the weight of the whole system stays the same, but the volume changes. So that therefore the density with respect to water changes, and that makes it go up and down. And then you would ask, so how does it go forward then? How you can, and that's by adding wings. So by adding wings, they essentially fly underwater, or they glide underwater. And then you can move a mass inside, up and down, or left and right here, to have a pitch, or you can roll the mass to have a roll. So essentially, you can go anywhere you would want to go. But so there's no propeller. But that means then they can have a really long endurance, but they are extremely slow. So they can go for months at a time, up and down the water column, in cross Atlantic, as you can see here. And they provide great data about our oceans, the whole water column, well, the top 1,000 meter of it, at least. So they are quite popular. They've been deployed all over the world. There is a huge amount of data generated by this. But essentially, when they are the scientists that get funding to deploy these, they do the deployment, they get the data, they publish it, and that's it. Maybe it just rests in a repository. And most of this data is open data. People can access it. But it is quite challenging for average citizen scientists to understand this data and visualize them. So we're not going to fix this in half a day or 1 day hackathon, a few hours of coding, but we can at least try. We can at least try to make a tool for doing something that is valuable. And that's for creating so the problem is that I am stating here is to create a tool for glider data visualization. And so you will be basically provided two sets of data. One is a very basic text file with columns of different variables. And the other one is a netcdf file, which is also a very well-known file for representing multidimensional scientific data. And there are tools on Python you can use for working with these files. And what you would need to do, what the basic things you would need to do is to visualize glider path, so where the glider went on a map, and some basic sensor data. So for instance, temperature and salinity against depth. So something similar to this, very simple path and just the temperature and salinity. But also you could, there are hundreds of other variables on this in this file. So you could really go crazy and just do one of these files, and you can pull data for bathymetry of the oceans and add that to your tool. So it's quite open what you can do. It's basically up to your imagination. Also be available on Discord tomorrow for questions. Maybe not in real time, but I'll try to answer it within a few minutes, I guess, maybe, or maybe 10 minutes or so. Okay, that's it. That's my problem, and good luck.
Cool. Hello. Okay, this is like a magic microphone that sometimes is on and sometimes isn't. But thank you so much. Thank you, everyone online. I don't think we have time for Q&A right now, but if you have any questions for anyone and you want links to things, we're going to send the slides to you. So you'll have them. And you can add people on LinkedIn and ask them there. Or if they're still in the room, you can still ask them, that kind of stuff. So thank you to the online people. See you later, I guess. And then we can finish the recording so I can put the microphone down.